Hello, everyone. My name is Stephen Maciong, and I will be your presenter today. If you can please answer a polling question while we wait for everybody to log on, that would be appreciated. Thank you. All right, at 87% voting participation, the results are 79% are interested in survey, 26% are interested in utility and power lines and substations, and 19% are interested in forestry up until this point. Good afternoon, everyone. Welcome to RIEGL USA's Applications with RiCOPTER webinar. To briefly introduce myself, for those of you who are new to my webinars, my name is Stephen Maciong, and I'm a technical sales and integration representative for the unmanned LiDAR segment at RIEGL USA. I've worked in this position for roughly a year and a half now, and before my time in sales, I worked in our support department, gaining valuable knowledge on RIEGL hardware and software. Before we start this presentation, please note at the bottom of the screen the question box. Please feel free to add your questions during the session, and I will do my best to answer them at the end of the presentation. The RiCOPTER is a RIEGL-designed UAS platform, which enables our users to have access to complete UAS to LiDAR system turnkey solution, from mission planning to data acquisition to data processing. The RiCOPTER is a reliable, fully redundant UAS platform to include redundant flight motors, flight controllers, and flight controller antennas, ensuring that in the event of a mid-flight hardware issue, that your pilot will be able to land the RiCOPTER safely, protecting your valuable LiDAR system. Let's take a quick look at the UAV-mounted LiDAR sensors that RIEGL has to offer. Taking a look at the top row of LiDAR sensors on this slide, we see RIEGL's VUX series sensors in the VUX 240, the VUX 1LR, and the VUX 1 UAV. These sensors were each designed with their own strengths. The VUX 240 is optimized for high-resolution corridor scanning, producing up to 1.8 million laser pulses per second, focused in a 75-degree field of view, while the VUX 1 UAV has a 330-degree field of view capabilities and a 5mm relative precision rating. Then there is the VUX 1LR, which was designed for larger projects where data needs to be captured at faster ground speeds. The bottom row of scanners is RIEGL's powerful lightweight MiniVUX series LiDAR sensors. The latest addition to the MiniVUX series is the MiniVUX 2 UAV, which maintains the same weight as the popular MiniVUX 1 UAV, but with twice the point cloud density output at only a few percentage points of bottom line cost more than the MiniVUX 1 UAV. All of the MiniVUX series sensors also have multi-target capabilities and have relative accuracy ratings of 1.5 centimeters. The MiniVUX 1DL rounds off the MiniVUX series as a cost-effective LiDAR sensor with a restricted 46-degree field of view, also optimized for corridor mapping. With any mission, pre-planning is key in getting desired results. Knowing this, RIEGL has designed a free software in RIPARAMETER, which will allow users to pre-plan their LiDAR missions, inputting key information such as project requirements, airframe type, terrain variations in the project area, aircraft altitudes and ground speeds, and even information on the targeted features that you're hoping to acquire with your data collect. RIPARAMETER takes the separate components and produces an expected output value. Here is an example of what information you can learn from the output of RIPARAMETER. Information such as suggested laser pulse rate repetition, scan rate, flight altitude, and ground speed. In addition, the software will output what point density you can expect in your data. So not only does RIPARAMETER communicate expected quality of data given your input project environmental components, but it also makes recommendations on which laser settings and flight parameters you should use to achieve the optimal data quality. Additionally, RIPARAMETER has a useful visualization area which allows users to identify expected flight swath widths and potential MTA zones. This is very valuable information for wide area mapping applications such as forestry, which we will discuss later. Also important, RIPARAMETER allows users to visualize point spacing of the laser pulses, which helps users avoid under or oversampling of your laser pulses on typically hard to capture features. Oversampling will create noise in your data, while undersampling or having your laser pulses spaced too far apart may limit the amount of returns from objects such as power lines. This leads us to our first application of the webinar, utilities, specifically power lines and substations. Utilities, specifically power management, is a massive industry that allows for society to function today. These power grids supply us with the energy to perform tasks as mundane as making your morning coffee to more adventurous tasks such as LiDAR data processing. Because it is in all of our best interest that we keep the lights on and continue to pump out deliverables, it is important that we maintain our power grids. And one way this is possible is by capturing data from a RIEGL UAV mounted LiDAR system. For utility applications, we look at RIEGL's VUX240 LiDAR system integrated onto the RiCOPTER. With this sensor's 75-degree field of view and high 1800 kilohertz pulse repetition rate, this system was designed to turn out feature-rich data. Outside of the impressive pulse rate repetition, the VUX240 is also capable of producing 400 lines per second, creating tighter scan lines, allowing for flexibility in ground speed and altitude, while still capturing the same returns from power lines of a lesser performing system. Tighter laser pulses are also important when it comes to scanning power lines, as the VUX240 has a laser pulse divergence rate of 0.3 mrad, which translates into a more focused laser pulse returns, which improves the amplitude of the return laser pulses, which in turn improves the overall quality of the data. Here we can view data screenshots of the RiCOPTER and VUX240 with APX20 IMU of power lines and transmission towers near RIEGL's manufacturing facilities in Horn, Austria. The view we are looking at now is a reflectance view type in RIEGL's data processing software, RIPRocess. The images you see now were captured by the RiCOPTER flying at 100 meters AGL and at ground speeds of 8 meters per second, with the scanner's pulse rate repetition set to 1.8 megahertz. This data was also impressively captured in only one flight pass. Notice how the complete power line was captured, which will help in measuring power line sag. Also notice how the transmission towers looks very defined in the data. This will help greatly for digital modeling of these towers. Just like in the previous slide, this is data captured near Horn, Austria from a utility substation and was captured with the same laser settings and flight parameters. The data you see here was captured with 6 flight lines in a checkerboard pattern, ensuring the VUX240 was getting several different looks at the features to ensure there were no dark spots in the data. With this information gathered, energy efficiency of the components of the substation can be monitored and replaced if need be. And that brings us to our second question. Our second poll, rather. All right. This is a bit of a pop quiz. What is the VUX240's max pulse rate repetition and max lines per second performance capabilities? Is it 1.6 megahertz at 300 lines per second, 1.2 megahertz at 400 lines per second, 1.8 megahertz at 400 lines per second, or 1.8 megahertz at 300 lines per second? I'll give it about another 10 to 15 seconds as some of the answers are coming in. We are currently at 40% participation. Okay, it looks like I have some attentive listeners. 63% of you guessed the correct answer, which was C, 1.8 megahertz and 400 lines per second. Just remember, when in doubt, Charlie out. Our next application that we will look at is forestry. Whether you are a company that deals with forestry management and controlling and monitoring vegetation growth, or a university that is trying to identify local tree species within a project region, RIEGL has UAV-mounted LiDAR systems to help you capture your valued data. For forestry applications, let's take a look at RIEGL's VUX1 UAV LiDAR system. The VUX1 UAV offers a max pulse rate repetition of 550 kilohertz at 200 lines per second while weighing only 7.7 pounds. But it's not just these performance features that make the VUX1 UAV a viable option for forestry applications. The highlighted feature of this sensor within the forestry applications is its ability to identify up to 15 targets per laser pulse. After a single laser pulse is emitted, it begins to diverge, increasing the area of the laser pulse. As this laser pulse diverges, portions of the laser pulse may come in contact with vegetation and reflect back to the sensor, while other portions of the laser pulse travel to the ground unobstructed and reflect back to the scanner. As the VUX-1 UAV receives these return laser pulses, the sensor identifies each laser echo pulse, up to 15 echo pulses, and powered by RIEGL's developed data processing algorithms, is able to attribute the correct timestamps to each echo pulse it receives. In this slide, we will look at layers of information that you can extract from your geo-reference point cloud. Users can create terrain models from the LiDAR data point cloud. Vegetation can also be highlighted for volumetric calculations, and canopy heights can be identified as well. With a baseline for canopy heights, data sets captured on different dates can be compared, and canopy height changes can be identified as well. All of this information can be exported into a 3D modeling software, e.g. Autodesk MicroStation or Esri's ArcGIS via RIEGL's RIMAP web app. Now let's take a look at a project that was flown with the RICOPTER and VUX-1 UAV in Lustdorf, Austria. The purpose of this mission was to collect data for flood and environmental analysis, which requires a LiDAR system that can penetrate the thick vegetation in the project region and create terrain models needed for flood analysis. Now let's look at a screenshot of data captured by the VUX-1 UAV for this project. The dark greens in this screenshot identify areas where there were greater than 1,600 points per square meter of subsurface returns, which is incredible density. Even the regions that are in red, where vegetation was denser, the VUX-1 UAV was still able to capture around 200 points per square meter. All of this LiDAR data was captured flying 14 flight lines, which produced an average of 1,500 points per square meter across the project region. The RICOPTER for this project was flown at 50 meters AGL at 8 meters per second with a 230-degree field of view and a pulse rate repetition of 550 kilohertz. The flight parameters and laser parameters were optimized for point density and RIPARAMETER prior to this mission. Now, capturing LiDAR data from the subsurface or identifying tree canopy height is important, but getting detail of the tree canopy itself can be valuable as well. By capturing this detail with more clarity, approximated volumetric tree canopy calculations can be derived, which can be used to model tree growth or monitor tree health. This is valuable information for logging companies to project potential timber yields, or for forestry management companies who perform controlled burns to reduce the probability of catastrophic wildfires. Here we look at camera options for vegetation identification. The VUX-1 UAV emits a laser pulse that is 1550 nanometers, but if different leaf characteristics require sensing from different electromagnetic frequency ranges, then we do have additional camera options available. The FLIR Tau2 thermal camera can cover your IR frequency ranges, while a hyperspectral option is currently being developed. If you are interested in colorizing your point cloud, RGB camera options are available in Sony and Phase 1 cameras listed in this slide. If you'll see here, these red circles are circling the FLIR Tau2 thermal camera. Our next application that I'll discuss is survey, and some of the components of a RIEGL LiDAR system that facilitate the survey grade accuracy that RIEGL UAV mounted LiDAR systems are capable of. RIEGL LiDAR in survey allows users to capture data over a project site, generate terrain models from which they can generate digital elevation models for future land development. Floodplain analysis and geological features can also be identified in the point cloud and delivered to your end customer. To deliver on accuracy, RIEGL has teamed up with Aponics and created integration solutions for the APX20, AP20, and APX15 Aponics IMU types for UAV LiDAR application. These IMUs are highly accurate and precise with a 200 Hz sampling rate. Aponics GNSS antennas, the AV14, and an option for the AV18 are also used to provide external reference to determine position for the IMU. RIEGL also recommends for best trajectory solution that a base station be utilized for your LiDAR projects. To tie your data down to survey control points, ensuring the best absolute accuracy possible, you can strategically place control objects over your control points prior to flying your mission. After the mission is flown, during data processing and RIPRocess, users can tie their imported control points to their control objects, align their point cloud not only to the correct datum, but also to the correct local survey control points. Another factor that needs to be considered when improving the quality of your trajectory and LiDAR point cloud is the vibration dampening from UAV platform to LiDAR sensor. RIEGL has created a mounting solution for the RiCOPTER that takes into consideration the weight, dimensions, center of gravity, and placement of the scanner on the RiCOPTER and have selected the best vibration dampening mounts to reduce noise in your solution. The final application that we will discuss today is construction. For construction, we see use cases for UAV LiDAR for monitoring the construction process, reducing profit loss caused by installation discrepancies, stockpile calculations, and 3D modeling of features for quality assurance. The colorized LiDAR point cloud that we see in this slide is actually RIEGL USA's North American headquarters that is currently under construction. The data captured in the screenshot is from the Minivux 1 UAV flown at 200 feet AGL at 11 miles per hour ground speed. For the construction application, let's look at the Minivux 2 UAV. The Minivux 2 UAV is a lightweight, cost-effective, survey-grade quality LiDAR sensor that features a 360-degree field of view and a max pulse rate repetition of 200 kilohertz, identifying up to 5 targets per laser pulse. Compared to the Minivux 1 UAV, the Minivux 2 UAV can produce twice the point cloud density while maintaining the same weight of 3.4 pounds. Further use cases for construction applications are steel beam placement validation, as users can overlay a 3D CAD model onto the LiDAR point cloud and see where there is misalignment. Other use cases could be to ensure anchor bolts for tilt walls are correctly installed, as the misplacement in these anchor bolts can prove costly in time for lost repairs and money. Other features in the construction process that can be monitored is utility right-of-way to provide accurate documentation of plumbing, electrical, and data lines entering and leaving the building. For this final slide, I want to talk a little bit about data fusion and what it means. Data fusion in this context is combining multiple LiDAR data sets captured from different LiDAR platforms. For the image on the left, we look at a data fused point cloud of RIEGL USA's headquarters with unmanned LiDAR data in orange, mobile LiDAR data in blue, and terrestrial tripod static LiDAR in green. If you look closely, each LiDAR platform offers a different vantage point, eliminating blind spots in your data collect. If you'll notice, the orange data points make up all of the laser points on the roof of the building, as well as the surrounding vegetation. The terrestrial LiDAR sensor seems to identify building facades and other objects in the interior of the building with more resolution. And the mobile system allows for a different look at the building from the road, capturing exterior wall data on a portion of the building which was hard to access by the terrestrial LiDAR due to personnel restrictions in the area of construction site at the time the data was captured. If you have further interest in learning more about data fusion, please join my colleague Tan Nguyen next Tuesday, June 30th from 1 to 2 p.m. EDT for his webinar presentation on data fusion. Now for the final poll question. Give it about another 15 seconds. Currently it's pretty even between the VUX 240, the VUX 1 UAV, and the Minivux 2 UAV. Okay. As the polls are closing, there is equal interest for the VUX 1 UAV and Minivux 2 UAV at 31%, and the VUX 240 just behind it at 29%. The VUX 1 OR has an interest based off this presentation at 8%, and the Minivux 2 UAV had a couple voters at 2%. Now, let me go ahead and view some of the questions that some members might have had during this presentation. If you have any questions, please submit them now. Okay, looks like we have a question coming in. Is the RIPRocess software used for photogrammetric processing? Photogrammetric, sorry, apologize. That would be incorrect. RIPRocess will not do any photogrammetric data processing, but you have captured the photogrammetric data with your RGB camera if you pair that with your LiDAR system. So if you wanted to and you were looking for a photogrammetric solution, you could find a third-party software to accomplish that. All right, there's also another question. If the LiDAR can penetrate the canopy, can it be detrimental to plants? Luckily, there were no plants harmed in the making of this data set, so there will not be any harm to the plants. All right, it looks like we are running out of questions here. Let me see if we get any more. All right, we have a question that just came in. Any success in penetrating water with LiDAR systems? And the answer is yes. For a UAV mounted solution or a helicopter mounted solution, RIEGL has just developed the VQ840G. If you would like to learn more information about the VQ840G, please contact myself or Mylin after this presentation, and we can discuss system performance, potential future demos, and other topics related to the VQ840G. All right, well, it looks like some of the questions are starting to slow down, so I'm gonna end the presentation now. If you have any additional questions, please feel free to call in, send me an email, whatever your best and most convenient method of communication is. So I just wanna thank everybody again for your kind attention. Everybody stay safe, and I will see you next time.